Welcome to another tutorial. My name is Chrognar, and this anime girl's eyes look crazy. It's like she doesn't care I live in my mother's basement. But this tutorial's not about that. This tutorial is about using a mouse with buttons to make a GUI. And we're going to be changing the color of her jacket because right now it's boring. And we're going to be using these buttons to change the color of her jacket to these colors. So let's go over the Blender file because making a mouse GUI takes a little bit more preparation. First of all, the model came from Vroid. It's an application that rapidly makes anime pretty boys and waifus. It's pretty fun. You can check it out on Steam. It's free. They make their money by selling the clothes for the characters and stuff, the accessories. But the fun part is that the top corner of this camera, in order for a mouse GUI to work, needs to be lined up with 0.00 in your Blender file. So the top corner of the camera in view needs to be lined up with the origin of the Blender file. So up here where this cursor is, this is 0.000. It doesn't matter the depth, but the z-axis has to be lined up with X on the 0 and Z-axis on the 0, this top corner, because of the way the mouse information works in UPBGE. Next, we got our buttons. These are each image textures that I imported as planes. These buttons were made with Inkscape. If you don't know how to use a vector drawing tool to make buttons, I guess you could try Photoshop or Krita, but for UI tools, you really need a vector program. And I'm not going to teach you that because you should learn that on your own. Or especially, if you're passionate about this stuff, you will learn Inkscape. All right. So next, let's go ahead and go over the materials. So the model for this is parented to its armature. So under the armature, we got an object called body. One of the changes I made to this model is I moved up its material for the jacket to the top of the list. So the base color of the jacket's on top, and then also the collar color is the second one down. So this one here is index 0 for the material. This one's index 1. If you don't know what that is, I will show you in the code. Next, importing VRM files requires a special add-on for Blender called It's called add-on VRM. You can get it at the Blender extensions website. It's an official Blender extension, so you can find it there. You can also look up VRM Blender import on GitHub. So this output material is called M2-1 material output. We're going to need to know that. Well, we don't need to know that. But what we did was I created an RGB node called jacket color to pipe that into the in-lighting color of this output node. This is a node group. Like inside here is actually the Evee output and the cycles output, but this works fine. And then also a brightness contrast. I lowered the brightness of that same color and piped it into the shade color of the M1-2 material output node. And that allows the shadow color to change with the jacket color. So that's for that. The only node we're going to be manipulating with Python is this jacket color node, and then it'll change both things because of the way the node tree is set up. All right, so this is about interactivity, though. So we're going to be making the mouse visible in the GUI. We're going to create a collider that'll track to the mouse. And when it hits these buttons are going to light up. And then when we click on these buttons, it's going to change the color of our jacket. So let's go. Next, we're going to input. We're going to import BGE. Actually, we should go ahead and test this in the game engine. So we'll press play to bring up the GUI. Make sure it comes up. Right now, the character's not visible because we have to make our armature visible. So she's going to look weird in UPBGE, but look great in the game engine. So go to armature, make it visible because it's the parent of all this. And then click in here, press play. And we got the buttons and the character. You can't see the mouse cursor yet because I don't have it enabled yet. I'll show you how to do that. All right. So let's close that. So first we'll import BGE. And we'll save this as a Python file. And we'll call it buttons tutorial. And we'll just call it buttons. Buttons.py. Alright, now it's in Python. We got our text highlighting. I put a disclaimer in here saying that the model was made with V-Roid, so no one sues me. Alright. And it's for educational purposes only. I swear. Alright. Next, we're going to create our KX Python component. So we're going to call this class mouse control. It's going to inherit from BGE.logic. BG.types. BG.types. KX Python component. Then we'll pass for now. Then I'm going to do for this we're going to need enums, so I'm going to import. So from enum, import enum. Save that. So why do we need enums? We need enums so we have easy access to switch statements. I'm actually going to be showing you how we can use the object names of our buttons to rapidly assign the object name to an enum. So it doesn't take a lot of code to change the state between the different buttons. So we need an enum. So we'll do class active buttons. Inherits from, I gotta change that to enum with capital E. And then we're going to create a first value called none active and set it equal to 0. We'll create a button called pink button. We'll just call it pink. And we'll set it equal to 1. Create another one called teal. Set equal to 2. And one called orange. And set equal to 3. This is so we don't have to memorize the ints or use like an array table. The active button's enum is basically a dictionary that with built-in functionality that treats it like an enum in C# when you use it, so that's pretty cool. But you can also do some Python things. So like if we assign a variable to this enum, we have access to its dictionary. So we can access it like a dictionary. So like if we inputted a string that was like non-active, it would output 0. So it can be very powerful. So, and we're going to use it with the object names of our buttons, which will be neat. So next, we got our enum set up. So now in Python, we have to actually create a collection called buttons. So we'll do that right now. So we'll select our scene collection, and we'll right-click on it and choose New Collection. That created a collection 3 here. We're going to call this one Buttons. And we're going to go to the primary collection and highlight our orange. Shift click to select our orange, pink, and teal button, and we'll drag it into buttons. And then we got to go ahead and rename these. We got to rename these button names to match our enum names over here. So we don't need one called non-active, but orange button has to be changed to capital orange. Pink button has to be changed to capital pink. And the teal button has to be changed to capital teal. All right. And then we're going to, I don't know if that's teal or turquoise. I don't know. Might be aqua, blue, green for all I know. I assume it's teal, but I could be wrong. Maybe teal's a type of purple. But I don't care. It's teal. Next. All right, we got that part done. So now what we got to do is we got to go ahead and we got to make our mouse visible. So we'll do that. So in I'm gonna go ahead and let's go ahead and import this script into save it, and we'll import it into UPBGE. So we'll click on Open button in the text editor inside UPBGE, and then we're going to navigate to it. So Desktop, Tutorial 6. Oh no, it's in my UPBGE folder. And there's the buttons.py. Open it up. Okay, it's been brought in. And we'll save the file. And then we'll go ahead and press play again for now. So we need to get the screen width and height here. And also we need to make the mouse visible, so we'll do that first. So in our component, we're going to need to create args, because all Python components require args to an empty dictionary at least. And then a function called start. Pass. And a function called update. And pass. Then we'll save it. Then we'll reload our script. And then we're going to create a empty off to the side here. So I'll select the cursor, move it out here. Do Shift A, empty. And we'll just do arrows. And we'll move it a little bit more away. Okay. Right now that empties in our buttons collection, but we should move it up to the main collection, I think. Yeah, because we don't want it referenced in buttons. All right. And we'll just leave that empty there. It could be called empty, it's fine. Then we're going to attach our script to it. So script is going to be called buttons dot mouse control. It's capital mouse, capital C, M, capital C, because it's the name of our class here. And then the file is named buttons, so it's buttons.mouse control. Click OK. And I get an error because I named it Buttrons. What the heck are Buttrons? Sounds like a evil robot villain name. Buttons dot mouse control. Okay. Good. All right, first we're going to go ahead and make the mouse visible. So in the start function, we'll do BGE dot logic dot mouse dot visible is equal to true. And we'll press play. And now our mouse shows up in the window, so that's good. Gives us places to click. All right, so we'll close that. Next. We actually need a we need to get our screen width and height. So we have to measure our screen width and height in the space area, because our collider for our mouse is going to be in 3D space. So you need to click here, get the mouse cursor there, and then under press N, go to view, and then under under 3D cursor, we need to make sure it's set to 0. It's pretty close. So the top position is 0. So that's giving us, that's fine. Then we got to get the other far side of our screen. So we'll scrub the X over here. We'll just click. Okay, this is pretty small, so our it's fine. Doesn't have to be huge. So let's zoom in on it, make sure we get it right. So we have to raise our camera a little bit, so we'll click on our camera real quick and get it up to that red line. So I press G and Z, move up our camera to be with the red line. Switch to our cursor and click on let's deselect the object. There you go. Click on our cursor, click here. And we'll move it down a little bit on the Z axis. Oh, that's too much. We'll just click and get it close. Then I'll hold down Alt to drag a little bit. Oh, no, that's not working. I will do it like that. Okay. So it's 3.6, we'll say it's 3.67. Nah, 3.665. Okay. So in our code, our screen width needs to be self.screen width is equal to 3.665. And our screen height is going to be less than that. So we're going to go down the bottom of our camera. Zoom in up. And we'll click here. And then our Z height is 2 point. We're going to ignore the negative because we just need that number, 2.066 m, or yeah, meters. So this will be. Oh no, we do need the negative, don't we? Okay, yeah, because that's its point in 3D space in Blender. Okay. So screen height is equal to 2 point. That one we can approximate. We could do 2.07. We'll go ahead and approximate this one to be 2.67. Keep them values not too long. Okay. And these are float values. Okay. So next is we're going to do our. We need to create a variable to get the mouse position. So we'll do self dot mouse POS is equal to BGE dot logic dot mouse dot position. This is what we call a normalized position. So if I look at the documentation here, it says, I'll click over here. It says the normalized X and Y position of the mouse cursor. Now normalized means it's going to, instead of it being coordinates in 3D space, it's going to be a value between, some float value between 0.0 and 1.0. So 0.0 and 1.0 based on the size of the window or the screen. So that's why we had to move the camera position to this corner here is at 0, 0, because we're going to need it to multiply by properly. So, all right, next, we have to create a mouse position list. So we're gonna, for 3D space, so we'll call this mouse 3D POS and set it equal to 0.0, 0.0, and 0.0. Right, next, excuse me, I had a burp there. All right, so next, we need to go ahead and create a function that's going to handle the relative mouse position. So I like to call it mouse transfer. So mouse X for, call it anything you want. Call it mouse is here, right? Call it mouse is cow. I don't care. Just give it a function. Next is BGE dot logic. Okay, so we already got that. So So we actually, yeah. So we need to go ahead and declare this variable again because it needs to update every logic tick. So we're going to do mouse.pos. Mouse underscore POS is equal to bg.logic.mouse position. Then we need to next we need to actually access this list here, positions that will correspond to the X and Z axis in 3D space. So gotta do self dot mouse 3D POS is equal to position 0, which is the x-axis of this list, will be equal to self dot mouse POS position 0. Times the screen width. So first, to show you this, I'm actually going to do a print of bg.logic.mouse.position. And we'll save our file. And then down here at the bottom of the screen, we're going to see the print output of that function. So when we press play, you'll see as I move the mouse around, the coordinates of the X and Z axis are changing, right? But they're between 0 and 1. If I go up to the very top here of the window, you'll see that they're basically 0.00. And if I go to the bottom corner here, it's 0.11, right? It's pretty close to 1.0, 1.0. So that we have to use these values to multiply by the X and Z axis in 3D space to control our mouse collider when we make it. All right, so down here you'll see we have it's a tuple. So this tuple here, mouse position, BG logic mouse position. This is our X value, and this is our quote unquote Z value. They call it Y, but we have to get position 0 of mouse position because that corresponds with this first item in the tuple. And then for height, we have to do self.mouse 3D position index 2, which is this value here, the Z value, because Z is the height axis in Blender. And then we'll do self.mouse position index 1. So it's equal to index 1 times self.screen height. And then what we can do is we can go ahead and put this mouse transfer function in our update. And then we can print our mouse 3D position variable. Then when we run the game, you'll see we have we have two entries now, right? We have our X and Y position over here for the mouse in 2D space, and then we have the position of the mouse in 3D space based on our little algorithm we made. So this is the position on the 2D plane in the window, and then this section here, this list is the 3D coordinates of the mouse in the game space. It isn't actually that yet because we haven't applied it to a collider, but it's there. So it's there in memory. All right, so next we need to go ahead and create a mouse collider in UPBGE. So we're going to click into UPBGE, and we'll put our cursor here. Make sure it's on 0, 0. It's pretty close. Okay. Then we'll do Shift A, and we're going to add a cone because we need something with a point to it because we need to be pretty exact. So we'll import a mesh cone. And then we're going to rotate it 90 degrees on the x-axis, so RX90. Then we're going to shrink it down. And we want to get it pretty small because we want it to have near, this collider is also basically our live zone as opposed to our dead zone for our mouse. So we want it to be pretty close to the size of the mouse. So something like that, something small. But we need it long enough that along the 0 axis it actually collides. So that's pretty good actually. Let's go ahead and move it back a bit on the y-axis. We'll scale it up on the y a little bit so it points through, so when it'll actually collide with these buttons. And then we'll call this mouse collider. And then in our code, we're going to create a function called mouse movement. And I could call it mouse cursor, but it's called mouse movement. And then we need a mouse collider, so we got to import that. I'm going to save this blend file just so in case it needs it saved. So we're going to create a local variable, this function called mouse collider, and set it equal to self.object.scene.objects mouse collider. And then the next and what we want to do is we want to get its world position and set it to this list we created, right? So this list that's updating the 3D coordinates in Blender, we want to set the position of this little cone object here, right here, to make sure it matches the coordinates in this list. So we do that by just doing self, we'll say mouse collider dot world position is equal to self dot mouse 3D position. And we'll add that function into the update, so self.mouse movement. And we'll save it. Reload our script. And we'll press play. We may need to make that thing bigger. And it needs a material so it's more visible, because right now it's as gray as the background. So let's give it a white dot for now. So we'll give a new material. We'll make it white and we'll raise its emission so it can be seen. There we go. Let's go ahead and scale it up a little bit more. We'll press play. It's getting close, but it's not quite there. Something's off here. Let me find out. Okay, it's showing up at the top. Oh, I see what's going on. Okay. So we got our screen height. So this value has to be negative. I thought I put that in, but I guess I didn't. Okay. So we corrected our screen height to be on the correct axis, and now if we press play, oh, go back in here and press play. There we go. So our mouse collider's tracking to our mouse. Seeing the printouts, it's updating the screen position at the bottom there. So that's pretty neat. So we'll exit that. And we actually need to go ahead and make this smaller. So let's go in here. So it's poking through probably a good size for compared to the buttons. So it's going to be invisible anyway, so that's probably a good size for it. Right, so we got that set up. So the next thing we need to do is we need to write the script for our mouse collision that collides the buttons. So go ahead and get rid of this print statement because we need to print collision events in a minute. So now we're going to create a function called mouse collision. So it'll detect what buttons are created or it collides with. So we'll do mouse collision self. And we'll go ahead and copy our mouse collider here. Our import statement. Can. There we go. All right, so we need a, so we created this collection called buttons up here in UPBGE. It's called buttons. And then I need to move that mouse collider though to the general collection. Okay. So we got our buttons here, orange, pink, teal. So what we want to do is we want to be able to iterate through this. Iterate means to go through each object, right? So we need to iterate each object in this collection of buttons. And to do that, we're actually going to need to import the BPY class. So I can type import BPY. And then what we're going to do here is we're going to create a collection called button. We're going to create a variable for our buttons collection. So to do that, it's BPY button collection is equal to bpy.data.collections, then the name of our collection, which is buttons. Then we need to actually do a for loop to iterate through each over and over again to basically cycle through this list of buttons. And so we're going to do for button in. And then the cool thing about the collections is that it's similar to a scene. So you could do button collection.objects. So for button in button collection.objects, we need to import what that button is. So we'll say button is equal to self.object.scene.objects. And then to get the button, rather than putting in a string for each button, right? Like if we were dumb, we would create a pink variable, an orange variable, teal. We're not doing that. That's dumb. That's wasting time. So we're going to use button, which will be this temporary variable here, which has all the methods of the object. We'll do button.name, and that'll return the string of the object's name. Then we'll do each of these buttons has an emission shader on it. So if I go to the shader panel, select the object, you'll see here it brought in principal BDF, and there's an emission section here. So we got that. So what we're going to do is we're going to make it so when the mouse is over the button, the emission's going to change so it lights up. So we'll make these buttons light up. So we'll say emission is equal to button, referring to this variable here, dot Blender object have an error. Okay. Mission is equal to button dot there's something wrong with my button variable for some reason. Oh, scene, that's why. Okay. Self dot is equal to button dot Blender object dot active material. And then we have to go to our tooltips, and don't forget to enable your tooltips in the preferences under interface. Make sure Python tooltips is highlighted. So the emission strength is value 28 of inputs in principal BP BSDF. So we need to bring in principal BSDF. So we're going to do active materials dot, oh, I got it, dot node tree dot nodes principal BSDF dot inputs, or is it inputs or index? Dot inputs 28. And then we need to go ahead and create our collision. So when the mouse cursor collides with these buttons, we have to create a collision state. So collision is equal to button dot collide, and then it's colliding with the mouse cursor variable. So then mouse cursor. And then we need to do our if statement. This returns a boolean as to whether the mouse variable hits the button variable in this for loop. So we'll do if true, it's a boolean, so it's either going to be true or false. If true in collision, we're going to change the emission value of the object that's currently being iterated through. And I need to spell emission correctly. It's bothering me. All right. Emission dot default value is equal to, let's do 2.0, 2.5, 2.0. And then else we'll make it fade, so we'll make it a little dim. So if the mouse is not over it, we'll set the emission value to 0.5. Then we'll save that. And then if we've done that right, check the order of my functions. So we want to be checking for collision at the get-go. So we'll do self dot mouse collision. We'll save it. And then if we reload it and start the game, now we mouse over it. Oh, no. Interesting. What we not do right here? I'll be back. Oh, I know what we gotta do. We still have to use our Enum. Think. No? I'll be back. Alright, I remember now. So, the collisions in Blender are handled by the physics system, so we need to make sure we apply the right physics to this. So, the only physics that initiate a collider currently, I believe, are the character physics, the rigid body physics, and the dynamic physics. So what we have to do is we have to select our cursor here and go to the physics section. And we need to change the physics type of the mouse cursor from static to character. We need to set everything to 0, so we'll do step height 0, jump force 0, fall speed definitely has to be 0. Max jumps, we don't care, we're not initiating any. Yeah, we don't care about that. But we could go to collision bound, set this to 0, and then set it to cone. Alright. And then we're going to view it in physics view, so we'll go to the render section and click on physics visualization, and then press play. It'll show the bounding boxes of our colliders, and it shows where it hits stuff. So right now it's hitting the character model. We see where the hit points are. And then when I click here, you'll see these actually light up now. So we'll get rid of the physics visualization. So we'll close the game here. Uncheck physics visualization, and now when we launch the game, the code was right, which is good. But there. Now when we light up, it goes pink, teal, orange. So we got some interactivity and some feedback now. So that's good. And because brighter things pop forward, it has almost a cool 3D effect to it too. But you notice these aren't glowing. I think we should make these glow, don't you? So what we're actually going to do is we're going to go to the compositing section of our screen under the compositing tab and click on use nodes. And under the compositor here, we'll move the composite node over and we'll press Shift A and we'll add a node called glare. We'll set that up and let's change this to, let's do ghosts. Ghosts look cool. No, let's do bloom. Bloom's typical. Because in Evee you need a glare or bloom effect to get the highlights of it, and then we'll go ahead and lower on the highlights we'll lower the threshold to like 0.1. Then if we go back to our layout view and we set under this arrow here next to the renderer, if we set our compositor to camera, see they light up now. And then if we go ahead and press play, she's glowing too, but see now they really glow. A little bit too much, so we'll change that. So let's go to compositing, and we'll raise the threshold to 0.2. Go back to our layout, click in the window, press play. She's still pretty pale, but the buttons are looking better. Orange looks great, but these ones are kind of, teal's too bright, so let's go ahead and adjust it again. Back to compositing, we'll go to our glare node. Can actually raise the smoothness out, and then we'll go ahead and make this 0.4, make it more subtle, and then lay out. I think what else we can do with that? That's probably fine. Okay. This is a tutorial, doesn't matter. Alright, so press play. Pink, teal, orange. So we got interactivity, isn't that great? Alright. With a glow. And then we'll go ahead and click X. Alright, so now we have, I think we can go ahead and hide our mouse cursor. So we're going to, in our main collection, under Mouse Collider, we'll disable the render. Now when we press play, we only see our mouse, and when we mouse over, isn't that great? Alright, so we got some feedback on the buttons, but they're not doing anything. We can click on them, nothing happens. Her jacket is not changing color, and that gray looks terrible. Not that I care about that, but we're here to change her jacket color. So next, we need to detect our button's active state. So this is where our enum's going to come in pretty soon here, but because we got these capitalized names, we actually need to return them as a function. So we're going to basically copy most of our mouse collision function here to there. We'll paste it, but we're going to give it a new name. So this is going to be button active state. And it's still going to be, go ahead and copy this from up here. Paste that there. And then we just need the collision. So collision is equal to button.collide with mouse collider. And then if the collision is true, we're going to create a variable. So we are actually using our enum, starting to use our enum. So we're going to basically, when it's not touching a button, our button's enum is going to return none active. So we have to create our button hit variable. So we'll do button hit is equal to none active. There's a reason why it's a string right now. It's really cool. You can do this with enums, so you'll see. And then we're going to return button hit. And then if true is in collision, we're going to set button equal to button.name. So if the collision is true with one of these buttons, it's going to get this capitalized name over here, right? Orange, pink, teal. And it has to be called button hit. And then it'll get the name of that as a string and return that string as a capitalized string, right? So now we need to make our next function, because we're actually going to go a little bit functional on the programming here. We're going to make this function be an input to another function. So we're going to tier our functions a little. So we got our buttons active state. Actually, we could test this by go ahead and putting it down here, and then we'll put in a print statement. So we can do print self.button active state as a test. We'll save our Python file, and then when we play the game, right now it's returning non-active down in the console, right? And then if I put over pink, it changes to pink. Teal, it changes to teal. Orange changes to orange, see? And down here in the Python console, it'll change to pink, then teal, then orange. And it's returning the object name, so that's cool. That's data we can use. So now we've done that, we're going to create another function to put it into. So we're going to create, this is for our click function, so we're going to do mouse left click. And it needs to accept an arg. So we'll give it arg1. And now we're going to finally use our enum. So we're going to do active buttons. Oh no, we're going to do active button is equal to active buttons, our enum class from up here. But instead of calling it as a class here, as a class object, because the enums class is pretty awesome in Python, we can actually make it a dictionary and access the string name of it, and it'll return it as the enum. So we'll do active button is equal to active buttons arg1. Then we got to import the mouse, so mouse is equal to bge.logic.mouse. Then we got to create an event variable for the event of a left mouse click, so we'll do left click is equal to BGE events.left mouse, left mouse. And then we need to basically, we also have to do the just, we only want it when we click down. We don't want to hold down the mouse and have anything, so we're going to create a pressed variable. Or, yeah. So a pressed variable is bge.logic.kx input just activated. And then we're going to say if pressed is in mouse dot inputs left click dot q, and then this is the long part of the longest function. This is our switch statement based on which button we're hovering over. So we have to match arg1. So match arg1 case active button dot pink. We'll do a pass for now. Then case active button. We'll go ahead and just copy this 3 times. and paste it 3 times. Okay. So active button's pink, active button teal, active button orange. Then we have to do something with this. So right now it'll basically, so we need to change the jacket of the color when we click. So we have to access that info. So to do that, we have to get the material tree. So I moved that over. Let's move this back. Let me look at that straightened out. Okay. All right, so we need to go to the material tree here. And so we have an index 0 and an index 1. So we need to go to the object. And we need the object called body. So right here we got body selected. And the node we need to get is this node. And because we have the Python tools enabled, we can see where it's at. So it's gosh, that's a long name, but we got to use it. Okay. Right, we get out of OBS, get back here. Okay, so we gotta do body is equal to self.scene or self.objects .scene .objects body, then do jacket color is equal to body dot BL data blender object dot we're gonna do so our material index here should be material ID. Let's just do material. We'll just do active material. We'll leave her color gray. It's fine. So we'll do active material, node tree, nodes. And this has a really long, obnoxious name. So we'll look at it in the, maybe we could copy and paste it. So we'll go to our material. The material of the jacket is Control C, click in here. Yeah, got pretty close. I think that worked. Cool. Okay, so node tree, node. Oh, okay, so we could do. Could just do material, right? No, we're not gonna bother with that. Just gonna do active material. Undo that. Okay. So we don't need that string, we need a different string. That's one I can't copy and paste, so. Oh, it's easy, it's jacket color. Okay. So nodes, jacket color. That's why I renamed it. So node, jacket color. If we mouse over here, we see the tooltip. Oh, do I need to save it? For some reason, it thinks it's called Jack. JAC. Let's try renaming it. Select the node. Try renaming it to jacket color, all one word. Now I mouse over. Okay, I'm gonna trust that it's jacket color, so we'll do that. Then we'll do dot. Is that default value? Yep, default value, and it's RGB. So input 0, 1. Okay. Okay, we got that. So we have to create our tuple for our color. So we'll go back into Blender and we'll go to our character here. We'll hide the armature for a sec. And then we can change the jacket color here. So our first color is pink. So we'll go to pink. Yeah, it works kind of well. Looks good. Okay. And that color value is 0.4, basically 0.5 red, 0.07 green, and 0.43 blue. So we'll create our pink, say pink is equal to 0.5 red, 0.07 green, and 0. Let's mouse over it. 0.5, 0.07, and 0.43. Okay, and then we're going to copy all these, paste them in here. Paste in there. And we got change this color to teal. Oh, let's do teal. Okay, so our teal color is going to be that's 0 on red. .5 for green. And 0.64 for blue. Okay. Next we got orange. Okay, and orange is 93 red. .35 green. And 0 on blue. Save that for now. And then we're going to make a change to the note. Now we have to make a change to the color. So let's go ahead and straighten out my GUI and there we go. Okay, so we got that done. So now let's go ahead and go back. Let's get this back to gray. So we're going to click in here and press undo a few times. So we get it back to gray. There we go. All right, next. We got that done. So now all we got to do is apply. Okay, go ahead and move. GUI over a bit here. Okay. So now we got to apply these bliss to the jacket color. And if we go back to the model for a sec and click on the color here, we see that the tuple value is called default value. So it's going to be outputs. It's going to be called dot outputs. So yep, okay. So means that jacket color dot outputs is equal to teal on this one. Go up here. Jacket color dot outputs is equal to pink. Jacket color dot outputs is equal to orange. So to review, the button active status is going to return the name of the button hit. It's going to go into args and return the capital name of the buttons here. Then in this function, that string that's capitalized gets passed into the enum and returns the enum. Then if the mouse click happens, if that enum is state pink, it'll import the model and its active jacket color node. Creates a pink list and then sets the jacket color to that. Then with teal, imports the object, gets the node from the jacket color node, sets it to teal, or creates the teal list, and then assigns the color of the jacket node to teal, and then it does again for orange. So we've done that. We can do go ahead and get rid of this print state. And so we'll do self dot mouse left click accepts button active state as its input. We'll save it. Go ahead and clean up our GUI a little. Right. Click in here. I've got to reload our scripts. Let's see if I did this in one shot. Or do I got errors? May have done it in one shot. See what happens when I click pink. Nothing is happening. I don't got any errors either, so I wonder what's going on. Oh, I bet we have to match what the output is in Blender. So if I go ahead and go ahead and split my window and go back to shader nodes. Go to RBG node. Okay, so the name's RBG. So we'll go ahead and change this node name to RBG. Hopefully it's the only one in here. This could cause some really weird behavior if it's an instance somewhere else, but we'll find out. Okay. Reload our script. Click in here and press play. Mouse over mouse when we click. Nothing happens. I'll be back. I realized what I did. I didn't even use the enum I created, like a dummy. All right, so let's bring this back. Move our GUI over a little bit here. Remove UPBGE over. Then if I go ahead and go into, so I have to use this active button. So our match case needs to be match active button. Reload our script. Oh, output is read only. Okay. All right, so we can't do it to the entire um, shader node. So shader node RBG is a tuple, so we have to access it through its individual. It is a list, but it's a read-only list, so we have to access it through its. We have to access it through its inputs. So go back to our jacket color node here, click on it, and mouse over this. So it has to be default value. Okay. Oh, that's what I did wrong. Okay. So it's output 0. So change this to output. Yep. Let's fix that. Yep. Okay. This needs to be dot output 0. There we go. And then this needs to be changed to jacket dot default value. Jacket color default underscore value. And we'll make it look nice. All right. So we've updated our script. Let's test it out. I don't know how I feel about it, but we'll see. Pink. Oh, 4 items. We need the alpha channel. Okay. So we have to have the alpha channel to each of our lists here. So 1.0. In our teal color, we need 1.0 as alpha channel. 1.0. There you go. And we'll do it again. but it's actually reacting, so it might be all right. Pink. Hey, it worked. Look at that. Teal, orange. Teal, pink. There you go. We have made a very cheap character creator. Alright, so that's how you do a GUI with buttons. So we'll do a quick review. I know it's already a long tutorial, but here we go. So, the main points, your camera, the top corner has to be at 0, 0, right? You have to have variable screen width, screen height. You need to set the BGE logic mouse visible to true. You need to create a mouse position, get the mouse position tuple from BGE logic mouse position assigned to a variable. You need to create a list for the mouse position in 3D that has 3 values. Then what you're going to do is you're going to multiply, you're going to get 3D position by basically saying that it's equal to, the first value here is equal to the mouse position, which is between 0.0 and 1.0, times the screen height. The 3D mouse position is then the y value, that tuple, times the screen height and the screen width, right? For the mouse movement, you set the mouse collider's world position to the same as this list here. It's important that your buttons have capital names if you're going to use them with an enum, so they return an enum when their string is returned in a function. See here, using a for loop through the collection of buttons, right? You use this for loop, and when the mouse is over it, it raises the emission value. To see the glow of them, you have to enable the camera mode on compositor under this arrow. And in compositing, we use the glare node. Let's change it to ghost for a second and see what happens, because we're having fun now. Things are working. It does that in the center. That's kind of cool. Okay, let's use it. Oh, look, that's kind of neat. Yeah, let's not use ghosts. Let's go back to balloon. I'll try fog glow. It's more subtle. It's not bad. But go back to glare. Bloom. All right, there we go. Yep, that's way cooler. All right. Okay, so yeah, I set that compositing under camera. Next, getting the button active state. So our for loop basically cycles through and checks what the mouse is over, which button the mouse is over, and if the mouse is over it, it returns the button name as a string and returns the value of that string. It gets inputted into our left click function, sets it to a variable, and then if the left button is clicked, it runs the switch statement that matches what the enum returned. And then it gets the object, gets the RGB node, assigns the color, Yeah, it creates the color list, then assigns it to that list in the node tree. And then finally, update runs it all. So we'll go back to it one more time. And click, changes to pink, changes to teal, changes to orange. So there you go. You have your own anime waifu generator. Anyway, I hope you had a great tutorial. Thank you for watching. Have a great day. Bye. Yeah, she probably likes guys that drive Ferraris.